Welcome to today's Explainer. I am absolutely thrilled to have you here with us today because, well, we're exploring a massive, literal, game-changing transformation happening right now on factory floors all around the world. We're looking at how artificial intelligence is taking traditional manufacturing and completely evolving it into smart, autonomous automation. So whether you're an engineering student, a seasoned PLC programmer, a robotics tech, or honestly just fascinated by the future of tech, understanding AI robots isn't just optional anymore. It is absolutely the foundation of tomorrow's industry.
Okay, let's dive right into this and briefly map out our journey today. We'll start with the smart robot revolution, move inside an AI robot, check out real-world industrial applications, weigh the benefits, challenges, and future, and finally wrap up with DEVI automation solutions.
Starting off with Section 1, the Smart Robot Revolution, from pre-programmed to intelligent.
Now, what's really interesting about this is the stark contrast between the past and the future of automation. Look, standard industrial robots are incredible machines for sure, but fundamentally, they're kind of blind. They just execute pre-programmed, highly repetitive tasks. So if a part on a conveyor belt is even slightly out of place, a standard robot is just going to grasp at empty air. But enter the AI robot. By integrating machine learning and computer vision, these machines aren't blind anymore. They're visual, they're adaptive, and they're highly intelligent. They can actually see that misplaced part, adapt their trajectory in real time, and get the job done. It is a complete paradigm shift.
Moving on to Section 2, inside an AI robot. Let's break down the anatomy of automation.
Think of an AI robot kind of like a human body, right? The robot arm and servo motors, those are essentially the muscles and the skeleton, providing all the physical strength and movement. Then, the sensors, cameras, and vision systems act as the eyes and the nervous system. They're constantly taking in data from the environment. And then we have the brain, the AI processor. It handles complex machine learning algorithms and works hand in hand with the robot controller and programmable logic controllers, or PLCs, to manage the actual physical movements. All of this is monitored via human-machine interfaces. It's protected by really advanced safety systems, and it's all hooked up to the wider factory network through an Industrial Internet of Things, or IIoT Gateway.
And this brilliantly illustrates how all of those specific components work together in real time through a continuous step-by-step loop. First up, the robot uses its cameras and sensors to literally sense its environment. Second, it collects that data. Third, the data is sent for AI analysis, where machine learning algorithms process what they're actually seeing. Fourth, the AI makes a decision, like, hey, this weld is a bit flawed, I need to adjust my angle. Fifth, we get the robot action where the servos actually move the arm. And finally, feedback is generated, which lets the robot learn and improve its accuracy for the very next cycle.
Because they have this incredibly adaptable brain, we aren't just limited to one type of machine on the factory floor anymore. We've got heavy-duty AI industrial robots for major manufacturing tasks, but we also have collaborative robots, or Cobots, that are specially designed to work safely right side by side with humans. Plus, we're seeing vision-guided robots for super complex physical tasks, autonomous mobile robots, AMRs, freely cruising around warehouse floors, and these hyper-specialized AI inspection robots that catch microscopic flaws the human eye would totally miss.
All right, Section 3, real-world industrial applications, or AI in its natural habitat.
The adoption rate across major sectors right now is honestly staggering. These AI-driven systems have become the beating heart of the automobile and rapidly expanding EV battery manufacturing sectors. They're assembling incredibly delicate components in electronics, ensuring absolute zero contamination in pharmaceuticals, completely revolutionizing warehouse logistics, and acting as the absolute backbone of modern smart factories.
So the crucial point here is how these robots actually apply their intelligence to specific, complex challenges in real time. Take AI vision inspection, for example. It detects defects in a product way faster and more accurately than any human could. In robotic assembly and welding, the AI ensures perfect precision every single time, which drastically reduces wasted materials. They handle highly dynamic pick-and-place packaging, manage autonomous material handling all over the factory floor, and this is huge, they perform predictive maintenance, meaning the AI can actually alert engineers that a part is going to fail before it even breaks. We are talking about saving millions of dollars in downtime.
Let's move to Section 4, benefits, challenges, and future, the big picture of Industry 4.0.
Look, on the benefits side, the gains are immense. We're talking extremely high productivity with way fewer errors, absolute pinpoint accuracy, 24/7 operations, and drastically improved worker safety since the robots handle all the hazardous stuff. However, these amazing benefits are balanced against some real hurdles. We're dealing with high initial capital costs, serious cybersecurity demands, and incredibly complex programming. But most importantly, the need for skilled manpower. This right here is exactly why learning about AI and robotics is the single most valuable thing you can do for your automation career. The industry is literally desperate for people who understand how to run these complex systems.
Let's see how this all builds into the ultimate vision for the future of manufacturing. We're definitely not just putting a smart robot in a corner anymore. We're combining artificial intelligence with robotics, the industrial Internet of Things, and digital twin technology. When you fuse all of these standalone elements together under the umbrella of Industry 4.0 and the upcoming Industry 5.0, the end result is the fully smart autonomous factory. It's an entire manufacturing ecosystem that can largely manage, optimize, and even heal itself.
And that brings us to Section 5, DEVI Automation Solutions, your industry partner.
We definitely want to highlight DEVI Automation Solutions, a premier industry provider who is actively out there making these advanced smart systems a reality. Their services are incredibly comprehensive. They cover everything from foundational industrial automation, PLC, HMI, SCADA, and VFD programming, all the way up to cutting-edge AI and IIoT integration. They even extend this expertise into smart agriculture, home automation, and solar solutions. If your facility is looking to modernize, definitely reach out to them directly at deviautomationsolutions@gmail.com. And hey, if you're finding this explainer valuable, please make sure to like, comment, share, and subscribe to the channel so we can keep bringing you these deep technical deep dives.
We have covered a ton of ground today in this explainer, from the basic anatomy of an AI robot all the way up to the fully integrated smart factories of tomorrow. Look, the transition from legacy automation to intelligent, AI-driven manufacturing isn't something that's coming in the future. It is happening right now. For engineers, technicians, and programmers, mastering these systems is absolutely critical to thriving in tomorrow's job market. So I want to leave you with this final, provocative thought to really ponder for your own upskilling journey. Are you ready for Industry 5.0? Thank you so much for joining me today, and as always, keep learning.